But hey, there's one. If we have a test next Tuesday, which was supposed to be Thursday, now it's next Tuesday, I'm guessing a forever quiz on Friday, because that's the first non-chapel day that we have this week, right? So we'll do forever quiz on Friday, test next Tuesday. Your homework spiral is coming up. If you guys haven't been coming in for questions, please, 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 I'll try to be here at least until 4 today again. I warned you guys yesterday about basketball games, but I forgot they aren't until later. She's alive. Wrong class, but she's alive. Morning, kid. You guys need to be keeping up on that homework, right? If you're behind, you aren't horribly, horribly behind. But if you haven't practiced antiderivatives yet, 4-1, it's going to really hurt in this next section, 4-4. And the rest of the motion you got to get on top of, and the area under the curve stuff. This homework, 4.3, which is homework number 28, should not be horrible. So let's quickly get through it because we got to get on to the next section. Oh no, my stylus is missing. It's somewhere. Why don't you try the top little drawer above my chair? Thanks, sir. If it's not there, try it. Never mind. Another one!
Okay.
What's a Kinko's? That's fun. Me too. Okay, here we go. We have this down from yesterday, properties of definite intervals. We gotta get going, and remind me, Aaron and Angela came in. Okay. What? What'd you get for a Klondike bar? Just kidding. What would you do with these given pieces of information? Are there graphs? No. Are there functions?
Yeah.
They didn't give us the equations and they didn't give us the graphs, so how on earth are we supposed to using properties and plugging in? Guys, these are just for whenever they give you definite pieces of information, they expect you to use them, right? Now, every now and then, can they give you too much information and try to trick you? Oh, yeah. But they gave us these for a purpose, for a reason. We're not doing any rectangles or trapezoids or craziness because we don't have a graph and we don't have a function to make a graph of. So how do we use the clues legally? Some of you guys want to make a quick guess as to what you think the answer is without showing any work, which is quite dangerous, and yet in this case probably. Nice. The answer is 16. Positive 16. However, we need to be able to not only get the correct answer, but show why. Yeah? So, why? We can use the rule number 5. We can also use the rule number, is it 3, the one with K?
Yeah.
Yeah. We can pull out a K. Oh my goodness. That's using K by pulling out 3, and then we can also use the sum and difference and split them up piece by piece, right? So why did 16 work? Because all we had to do was plug it in, plug it in. This clue ends up being 2 times 3 minus this clue ends up being -10. And PEMDAS says, of course, you have to multiply and then add or subtract, right? So 3 times 2 is 6, and 6 plus 10 is 16. If you knew how to do that, thank an algebra teacher. They taught you good and you were actually paying attention. It's just a clue, kids in algebra. Half of them might have gotten that simplification at the very, very end. Struggle. Okay, coming back. You guys have the clues written down, right? So I don't need to keep on showing them?
Yeah.
What do we do with this guy?
See how
Okay, we can pull K out.
It's 1 to 4.
Yeah, it's 4 to 1 instead of 1 to 4. That's backwards. How do we make that right? Put a negative in front and then change the bounds to the way that we want them and the way that they're shown up above more specifically, right? You guys see the property I just used? It's the property that says the integral from B to A is negative the integral from A to B. So if we don't like it the way it's shown, 4 to 1, which is pretty nasty, we usually like the smaller number or the more negative number on the bottom. Then we can flip it, but we just have to make it negative. Is that cool? Is it rule number?
I'm pretty sure it's rule number two.
It's rule number 2 and 3. Number 3 says pull out the 2, and number 2, property number 2, says if the bounds are backwards, flip it and make it negative. Is that cool? So negative 2 times, and what was that integral from 1 to 4 of f? Was it 3? Double check me because I don't have it shown. Oh, it's 2.
Yeah,
Aw,
it's negative.
struggle. So instead of negative 6, what should it be?
Negative 4.
Negative 4. I agree. You guys moving on to the next one already?
Already done.
Already done? The next one's, I think, kind of the trickiest one.
It is.
For this example, I want you guys to think of In-N-Out and McDonald's on Lassen. On Balboa? Yeah. How do you judge that? They have
2
many
miles.
doors. Which door is the main door? You usually go by like the front door. That's whatever your address is. What's the
2
front
miles.
door?
The
2
main
miles
door
west.
is like facing down last.
Wait, no, it's a mile west.
Yeah, so it's
A mile
facing
back.
like,
2 miles west.
it's facing the same way that we're facing.
Going right.
But In-N-Out would be facing Balboa, right?
Yeah.
Anyway, look up on Google Maps. Interesting question. Coming
Who's on the
back.
door though?
The main McDonald's are facing opposite. Yeah, it's strange.
Oh yeah. Anyway, coming back. Okay. I want you to think of In-N-Out and McDonald's down Lassen, Balboa, whatever. It's that cross section, intersection. Cross section is calculus. Anyway, so you guys haven't learned it yet.
Yes.
To get from here to McDonald's. To get from here to McDonald's. Couldn't you go straight from here to McDonald's?
Yeah.
Yeah, but what if you're like In-N-Out's milkshakes are so much better? Could you stop at In-N-Out first and then go to McDonald's?
Yes. Still be a 2
Would you still end at McDonald's?
Yes.
And would the distances still be the same ultimately as far as like GPS locations, not the few feet where you walk into In-N-Out and walk back out?
Yes.
Yeah. So to go straight here from here to McDonald's or go to In-N-Out, stop for a second, and then go to McDonald's, the distances are the same. Why am I saying that? We have the integral from 1 to 2. Yeah?
Yes.
They're asking the distance, the area between 2 and 4. We have the area between 1 and 2. And what other clue do we have about f of x and integration and areas and all that jazz?
Area of 1 to 4.
We have the area from 1 to 4.
Cool.
So if we have the area from 1 to 4, isn't that the total, like from here to McDonald's?
See.
And then if we go down below and say, okay, well, if the total distance from here to McDonald's, now we're, of course, saying 2 something. Brandon, that could be 2 half miles, right? You're saying it's a mile from here to McDonald's? Cool, so we'll say 2 half miles. So the distance from here to McDonald's is 2. And they tell us the distance from here to In-N-Out is -5. Okay, obviously that's not right as far as our example, but what could I say is going on from 2 to 4? Now, I don't want you guys to give me a number. Instead, I want us to write an expression. Couldn't we say the integral from 1 to 4 of f of x dx, that's the total area, right? Isn't that equal to each of the pieces from 1 to 2?
Yeah.
And then from 2 to 4? That doesn't let me move up. Let's see if there are people in the back. Do you see what I'm saying though? The integral from 1 to 4, the total area between or under f of x from 1 to 4 is going to be the area from 1 to 2 and from 2 to 4 put together. Yeah? Now what do we know? What can we fill in? Yeah, from the clues we can say the integral from 1 to 2 is -5 plus, we don't know this guy, so we'll just leave him unknown, 2 to 4 of f of x dx. And what's the other guy from up above? 2. Do we have ourselves an equation? Try and see if I can get it like this for, is it moving for you? Oh, it doesn't move for you. So 2 equals, maybe people that can't see it, listen verbally, 2 equals -5 plus the integral from 2 to 4 of f of x dx. All we have to do is a little bit of algebra to solve, and the final answer is?
2.
Oh no! Maybe algebra teacher failed. Just kidding. Add the 5 to the other side. Final answer is 7. You guys added 5 to the other side, right?
I did now.
Plus 5, plus 5, 7. Right? Oh, struggle. It's too early for algebra, huh? You guys thought it was too early for calculus. Alright, let's keep going. These ones, I need to actually write down the directions. Somehow they got erased in some version of the notes that I was doing some year. I don't even know. So, here we go. Express. Express the following areas using definite integrals. Express the following areas using definite integrals. What areas? Well, these ones, of course. The enclosed areas. That has to be super spiffy. I did this in period 6. We could say the enclosed areas. Express that as a definite integral for example A using these directions. Then we'll also do the same with example B down here below. Express the area using a definite integral. You don't have to solve it, even though we could. It'd be easy. It'd be area equals 1/2 base times height. But that's not what I'm asking for. Not this time. I'm just saying express the following areas. Who's got one for letter A?
Oh, integral.
The swoopy thing. Hold on, help us out. How do we say it? The
Integral
definite integral
of 0 to
from 0 to 2
of 4 minus 2x.
of 4 minus 2x. Give me a thumbs up facing my way and making direct eye contact if that makes sense. Uh-oh. 5 people. 6, 7. Ah! Make eye contact. Give me a thumbs up if it makes sense.
Eye contact.
Okay, that's better, that's better.
Eye contact.
That's better. Ella, does it make sense, kid?
Not really.
Okay, well hold on. Help us out. Angela, where did the 0 and 2 come from?
It's the base at the distance.
Good. Don't say distance though. Say the beginning x and the end x. Does that make sense?
Yeah, the beginning x.
Uh-huh. And then keep helping out, Corey. Where did the 4 minus 2x come from?
F of x is equal to?
Mm-hmm. And that's the function whose area under we're trying to find. And then why do we have this in an integral? Because it's the area under the curve. That's the definite integral's definition, or I should say description. A definite integral finds the area under a function between x values. And Ella, we just always do the integral as the beginning and the dx as the end. They kind of bookend all the math that's going on in between. So the notation is the outside and all the info's on the inside. Does that kind of make sense?
Yeah.
Cool. So then using that information, I want you guys to take a second and maybe you already have it and maybe you don't. Do letter B. Letter B is a little bit harder. Just do your best guess though. What do you think it would be? You should be able to right away do this and do this. What is dy? It's telling us, hey, everything's in terms of y. Exactly. But we need bounds, right? Wait, everything's in terms of y, and this is the y-axis, which means I'm going from 0 to 2. If you guys did 0 to 4, it was a good idea, and you have the general idea, but I tricked you because it's dy. It's in terms of y, so we need what kind of bounds? Y bounds. Hey, you guys just got a really complicated idea from actually 2 chapters in the future. Whoa! If it's in terms of x, you need x bounds. If it's in terms of y, you need y bounds. Why? Aha! Perfect. Who's on first? Okay, what do we do with this example? The directions on these ones are just to... Yeah, basically.
Oh, yeah.
Did you guys notice I updated Forever's last name?
Let's try to
Oh my goodness!
I checked if they were updated. I checked.
Oh my gosh, it was on Tuesday.
Teen Wolf is on Tuesday. Heck yeah, it is.
Alright, CalcAB shirts are on my list. Solve! Wait a minute, how do we solve?
Negative A on the left.
Negative A on the left, good, because that's an x bound, and how do we know it's an x bound? Because it says dx, right? Okay, so negative A on the left, whoever that is, what's going to be on the right? Positive A. Wait, who's 4? Isn't that the f of x, the function? Does that make sense? I hear you guys say it. So we can say y equals 4, right? Thanks, Charlie. Excitement. And what am I trying to find with a definite integral? Oh my goodness, how can they expect us to kind of figure this out? Geometry! Area equals. And what is the base? Woo, look at you guys. This is something we did in pre-cal last year. It's coming back to help us. 2a is the base. Right? A on the right, A on the left. What's my height? Look at you guys. Final answer, 8a. Done, done, done. Got it. Is that making sense? It's a rectangle, base times height. The base is going to be a here and a here. Remember, we're just doing distances. What? Why would I give you a homework problem? That's lame.
Even though you gave us 29 homework.
Sorry.
How many did I give you in 4-2? Oh, snap. Okay. Gonna be. Nah, it's just salt back and forth. Okay, so letter B. What do we do on this guy?
Start out with the bounds.
Got it. Now what though? We can plug in 0. So Katrina's seeing this as an f of x, and she's like, I have no clue who this guy is, so let's go ahead and make a little baby table. Hey, can you always go back to little baby tables? Sure, why not? Charlie doesn't like it, but the rest of us, let's try it. Plugging in 0. What's a minus 0?
A.
Alright, well we know it's at a at 0, right? Oh, because I plugged in f of 0, and f of 0 is a y value, right? So when x is 0, y is a. The point 0a. Is there anything else I can plug in? Wait, what if I plug in a?
0.
Ooh, that's 0. So look, he's down here. Hey, there it is. Hey. You're welcome. Wait, it's an absolute value function. It's been shifted vertically up A and it's been vertically flipped. You guys should know this. You see it? Right?
Yeah, it is.
So what are we trying to find?
What?
You guys go ahead. I'm going to have the answer in about 30 seconds. So see if you can beat me. Go.
1/2 area.
Are you sure it's telling me that?
Well, 1/2 2 1/2 3 is 1/2 3 is. Well, yeah.
It'd be a squared.
1/2 2 squared.
It'd be a squared.
2 is just
A squared.
It's A squared.
A squared.
So I'm just, well, I've got the one. Yeah, you can.
It was silent, right?
Dun, 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 dun.
Yeah.
You got it?
It's just having
Dun, dun.
pterodactyl.
Yay! Shush. Okay, so. Hey, we're done! Okay. I'm coming. There you go. Alright, start it. New section, new side. Very to be top. Section 4.4. Title. Let's see if this sounds important. Fundamental theorem of calculus. Oh, that sounds important. And guess what? We're going to go ahead and shorten it to FTC. Okay, like MDT and IDT and EDT and rolls. Section 4.4. Sarah, you good? Okay. Welcome. Section 4.4. The fundamental theorem of calculus. FTC. Katrina thinks forever smells good.
What?
She said she smells one coming. Yes. She's tracking it.
Okay. I'm not caught up.
I know she was.
I'm not either.
Oh, you're tracking.
I've missed like 2 seasons.
Me too. You can only practice multitasking. Shh. Go.
Wait, what?
There's like 6. How many multitasking?
Isn't that part of multitasking?
So you usually say only talk if you can multitask, so you'll get stuff done. Otherwise, you better be silent and be writing.
It's okay. Your sentence wasn't English. Oh my gosh.
You can only talk if you're multitasking.
But that's not what you. Yes, you can only talk.
So you can't multitask.
You're only allowed to be talking if you can write at the same time. There you go. Hey kiddos, you see a definite integral, right? Section 4.4 says, hey, let's solve this thing by hand exactly without rectangles or trapezoids and limits to infinity. Ooh, that sounds good. Guess what's coming back? Anti-derivatives. So all those skills that you worked on in section 4.1, you're going to put them to really good use in 4.4 to do what your calculator has been needing to do for you. Hey, what's this stuff? Key ideas. Hey, aren't we kind of reviewing everything that we've just talked about over the last 4 sections? Nope, 3 sections. 2 sections. 4.2 and 4.3. Graphically, what is a definite integral again? Area between an A and a B under a function f of x and the x-axis, right? Real quick, this area, since he's above the curve, is he going to be positive or negative? Positive. If he was below the curve, what would he be? Negative. Area is always positive, but we put a positive, we keep a positive on it if it's above, and we put a negative on it if it's below. Quick thing for you guys. We haven't practiced that a lot. Solved with geometry. When? Well, we can only solve with geometry when there's shapes that we know, right? Bless you. With geometric figures, meaning known geometric figures, meaning triangles, rectangles, trapezoids, circles, semicircles, quarter circles, etc., etc., etc. Approximated. What are the ways that we saw in section 4.3 for approximated? Do we have a forever card for this? Yes. When's our forever quiz? Friday. What is it on? Everything. Since the beginning of the semester. Meaning?
30 and
Yeah, because you guys were quoting over Christmas, so you should know where they stopped. With motion, what do we know so far about integrals?
Position is the integral, velocity is the integral acceleration.
Yeah, trapezoids. It's a title of respect. We're proudly.
I was gonna say genius, but.
Okay.
We know that, and we also know.
Buddy.
Okay, focus.
What?
I said, okay, focus.
Okay. Can't you ask something about that?
Okay. We also know speeding up and slowing down, kind of. But let's not do that right now. It can be abusive without hitting you. Anyway, algebraically. But it's by applauding you.
It's encouraging.
Algebraically? That's what we don't know yet. We don't know how to use antiderivatives, but we're going to learn it, so that's this section. This summarizes everything to do with solving a definite integral, and we know how to do everything but number 5. I thought you saw hands coming, I apologize. You guys got it all? Ready, set, and? Algebraically, let's go. Okay. Good news is I'm actually not going to make you guys write this. Pencil down, just for sake of time, because we were behind anyway. But I do want you to pay attention. Question. Do you guys remember, just a little bit ago, yesterday and the day before, we were talking about Riemann sums and approximating? Do you remember how we had this snazzy limit definition of an integral? And that snazzy limit definition was the limit as n approaches infinity of the sum from k equals 1, no, it was I equals 1, wasn't it? Sorry, in BC right now we're using summations of k. I equals 1 to n of f of, now technically they said c sub I, just for sake of illustration, I'm going to go ahead and do it this way. I'm going to do x sub I, delta x sub I, okay? So what are these little x1, x2s? Up to x sub n minus 1s. What are those? Points in the interval where we're splitting up for rectangles, right? Points in the interval where we're splitting up for rectangles. Okay. So that's what these little x1, x2, x3, dot, dot, dot are all for. We're saying there are any points in between a to b, which makes sense. We were sectioning off a to b. So a starts it, b ends it, and all these little x's are in between, sectioning off the subintervals. Ah, look, divide it into subintervals where we have this subinterval, that subinterval, whose lengths we denote delta x. Okay, if you guys notice, that kind of looks like that limit definition that we have up above. We have the delta x's for each of the bases of the rectangles, and we have the little x of 1, 2, 3s for what we plug in for the heights. Now, here's where fundamental theorem of calculus comes from. NVT, hey, that's an oldie but a goodie, right? Says there exists, I know it's messy in its notation, but that's okay. There exists I'm going to say x sub I star in each subinterval, we'll just say a to b, such that f prime of x sub I star equals f of b minus f of a all over b minus a. Now, what have I done? I've taken out the c and I've made it some snazzy x star, okay? So we recognize MBT as long as the function is continuous on the closed, differentiable on and open, there exists a special c within the interval such that f prime of c equals f of b minus f of a all over b minus a. Okay. So with all of that, we can say for each of these individual little baby subintervals, I know it's my iPad, sorry, he's just making like lights on the wall. Everyone looks. Come back to the smartboard. On every single subinterval, okay? On every single subinterval, we can say, for instance, on a x1, And then we can say on x1, x2. And then we can say on x2, x3. We can keep this going all the way until we get x sub n minus 1 to b. Okay, these are all the subintervals, however many we have, 5, 10, 100, 1,000,000. We can say the following. We can say that f of b minus f of a is equal to, if I solve this little equation by moving the b minus a to the other side, I can say it's f prime of x sub I star times delta x sub I, which looks an awful lot like that summation up there at the very, very top. So fundamental theorem of calculus tells me, or it pulls out of the following. We can say, fine, on the first subinterval, f prime of x sub I star times delta x sub I. Oh, sorry, hold on. This is the first subinterval, isn't it? 1 is equal to f of x sub 1 minus f of a. However, hold on, there's something that I kind of forgot. When we talk about little f, we're actually talking about capital F prime. So I'm going to change this notation really fast just to make it appropriate to antiderivative. So we're going to change that and this to the following. We're going to change this to f, denoting the function given to us in an integral. We're going to say capital F of x sub 1 minus capital F of a. And then we can say that's one subinterval. The next subinterval is going to be f of x2 star times delta x2 equals f of x2 minus f of x1. We can go again if we want to. F of x3 star equals delta times delta x3. Yeah, you see it? Is equal to f of x3 minus f of x2. Now this can keep on going until we get to our final subinterval, f of xn star delta x sub n equals f of b minus f of x sub n minus 1. Now if we're doing a Riemann sum, we would add all these together. The idea of this formula, once again, is we can have 5, 10, 100, 1,000,000, and this formula will still suffice. Now what do you notice about what happens with, if we add all these together, f of x1 positive and f of x1 negative? They're going to cancel. He's 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 going to cancel with the next guy. All of them are going to cancel. Who's going to be left? The definite integral from a to b of f of x dx is the antiderivative with the b plugged in minus the antiderivative with the a plugged in. That is the infinite sum. Woo! We'll solve those tomorrow. Get out of your school, kids. Thanks for hanging in there. I'm minute, and I'll see you later. Bye. MVT makes definite integration possible. An infinite sum and one subtraction. Bye, guys.
That was good.
Bye.